so we're going to do a review on polynomials. Polynomials, okay? So, example 1. It's definitely a polynomial. So to have it in standard form, you have to put the biggest first. The biggest really is the x to the fifth. So you write the biggest exponent first. I'm just going to write it down as x to the fifth, and then I'll go minus 4x cubed plus a 6x squared plus a 5x minus 1. Okay? You just go biggest exponent down to smallest. Easy. What's the degree? The degree is always the biggest exponent. That's it. The degree is the biggest exponent. It is 5 in this case. The leading coefficient is the number in front of the biggest term, so it is a 1. Even though I don't see a 1 there, we know there's a 1. Okay, the constant term is the number without a variable. Negative 1, right? The constant term is the number without the variable. Negative 1. How many zeros? It will always have as many as its degree. It's fifth degree, so it will have 5 zeros. Some of them might be imaginary, some of them might be square roots, but it will have 5, and some of them could be even double roots, but it will have 5 answers because it's the fifth degree, okay? Alright, example 2. I'm going to get my graph paper out because it looks to me like I might be doing some graphing. It's alright, we can do this. So, yes, you can use a calculator, but I think I can probably do this without a calculator. So, first of all, the vertex. It is in vertex form. The vertex is opposite, right? Negative 2, negative 9. Alright? The y-intercept. Well, let x equal 0. To find the y-intercept, let x equal 0. So you'll have y equals 0 plus 2 squared minus 9, which is 4 minus 9, which is a negative 5. So my y-intercept is going to be the point 0, negative 5. All right, let me go ahead and circle some of these things so I can come back and graph them. So I've got my vertex, I've got my y-intercept. Now the x-intercepts. The x-intercepts is when you let y equals 0. Now, just because I know how this graph looks, I'm going to get it from the graph. You okay with that? Just easier to get the y-intercepts from the graph. We could set this equal to 0 and solve. It's not that hard to do. But I think I'll do it by graphing. So let's graph this. Okay, so right off the bat, if the vertex is at negative 2, negative 9, let me get started on my graph. All right, let's go over there. There. Let's go to negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can use your calculator, but we're smart. We're squaring it, so I can go 1, 1, right? 2, 1, 2, 3, 4, right? 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? And of course, the other numbers are on the other side because it's symmetrical. I have a point here, and a point at there. Okay. How's my parabola? So I just did a t-table in my head, right? 1 squared, 2 squared, 3 squared. It's really quite easy. So now the x-intercepts are right there for me, okay? And if they weren't, then I would have to solve for x, but this was pretty easy. So I can go straight to my x-intercepts of, let's have my x-intercepts at 1, 0, and at 1, 2, 3, 4, 5, negative 5, 0, okay? How's that? Now, of course, I don't care if you use a calculator, so if you wanted to use a calculator, you could. You could have gone parentheses. Yeah, x plus 2 squared minus 9 and graph it, and that'll work also, all right? So you can also put it in your calculator. I'm okay with that as long as you can get the answer one way or the other. All right? Everybody good? Thumbs up? All right. Number 3. All right, what is the y-intercept? Well, this one is pretty easy. It's just going to be negative 15. So the y-intercept is when x equals 0. So the y-intercept is just 0, negative 15. What's the coordinate of the vertex? Now, there's a couple of ways to do this. I'm going to use my negative b over 2a, all right? And that's my formula for a quadratic. So my b is 14, so I'm going to have a negative 14. So it's a negative 14 over a 2 times negative 3. So I got a negative 14, which is a positive 14 over 6. Let's see, that's 7/3. 7/3 something, right? 7/3 something. So if I need the something, I plug the 7/3 in, right? So I know my vertex is going to be 7/3 comma something. So let me plug my 7/3. Let's plug it in for x. So I'm going to go y equals negative 3 times 7/3 squared minus 14 times 7/3 minus 15. And I'm just going to use my calculator, honestly, to do all that work, right? So I'll go negative 3 times 7/3 squared minus 14 times 7/3, subtract 15, okay?
Wait,
yeah.
If it's a negative b over 2a,
Yeah, it'd be positive 14.
positive 14.
Yes. Over negative 6. I didn't get the negative. It's a negative 7/3. Oh, I did make a mistake. Thanks, Will. What I didn't, it is a positive 14, but over a negative 6, so this is a negative 7/3. Thanks, Will. I would have had totally the wrong answer. Negative 3 times negative 7/3 squared. Thank you. Minus 14 times negative 7/3. Subtract 15. Now I got an answer about 1 1/3. Okay, so I got 1 1/3. Okay, there's my vertex. Now the zeros. Two ways to get the zeros. We could factor it, or we can get it from the calculator. You'd probably rather get it from the calculator, right? So there are three ways to get the zeros. 3 ways. 1, we could factor it, or quadratic formula. 2, we could graph it and find the zeros from the graph. 3, we could use the poly button. Poly's the easiest for me. I like the poly button. You guys like the poly button? So I'm going to use my poly button. For me, it is the fastest way for me to get the zeros. So I'm just going to go into apps. I'm going to go find my poly, right? And polyroot finder, degree 2. I've got a negative 3, negative 14, negative 15, and I solve. So it is. It's at a negative 1.6 or negative 1 2/3, which means that this thing would have factored. I purposely made it that way. So my zeros, according to my poly button, is negative 1 2/3 0 and negative 3 0. All right. Let's see if I can graph all this stuff. Okay, let me circle my zeros. Okay, so graph paper. And let's see what I can do. Alright. Alright, it goes way down to negative 15. I don't know if I'm going to get all the way down to negative 15, but I might. Right? And if you've already graphed it on a calculator, great. We're going to be able to get a lot of it just from what we have. So negative 7/3 is negative 2 2/3. Negative 2 1/3 and 1 1/3. So it's about there, okay? Negative 2 1/3, 1/3. My vertex is about there, okay? My zeros are at negative 1 2/3. It's about there, and negative 3. Okay. My y-intercept is way down at negative 15. I know 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, which means there's got to be another one over here about there, okay? So I just graph it in the best I can. Alright, now I'm sure that a lot of you guys are just going to graph it, right? So let's just take a look at the graph. Why not? Quit. I am on number 3. Yeah. So let's graph it, because I'm sure a lot of you guys are going to graph it anyway, right? So let's go to negative 3 times my x, 3x squared minus 14x minus 15. Graph it. Hey, it looks like just what I have, doesn't it? What do you know? What do you know? And I did mine without a calculator. Wow. What do you know? Don't feel sorry for me, but when I was a kid, these things hadn't been invented yet. When I went to college, these things were just starting to come out. That's why I can do fractions and so many other people can't, right? Okay, number 4. So number 4 says factor and find all zeros. So if it says factor, I'm going to be looking for that. So what I'm going to do is first, let's factor, and then the rest of this we can probably get from our calculator. Okay, so if it says factor, it's going to say factor, and I'm going to ask you to show your work. So for A, we're going to go 0 equals 3x to the 4th minus 16x cubed minus 12x squared. Okay, and then they have a common x squared in common. They all have at least an x squared in common, right? So if I factor out the x squared, I'd be left with a 3x squared minus a 16x minus a 12. Now, if I have to factor that, I got to be a little clever. Lucky for me, I am kind of clever. Just kind of. I'm not saying I'm clever. I'm just saying kind of clever, okay? So let's see if I can factor this. All right, parentheses, 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 parentheses. Now, the multiples of 3 and 1, right? The only way I can get a 3x squared is with a 3x and an x. Everybody agree with that? It's got to be 3x and x. I mean, at least I made it, so it's not super hard. Multiples of 12, there's lots of them. There's 1 and 12, 2 and 6, 3 and 4. So I'm not sure which ones I want to use, but let's put some numbers down and try it. Let's try 4 and 3 first, okay? Okay. All right. I hear it's 2 and 6. 4 and 3. So let's see. That'd be a 4x, 9x. You guys see the 4x? 9x. That's not going to make a 16, is it? Okay, but what'd you hear? I heard 6 and 2. Is that what somebody said? Okay. Did you put the 2? You probably need the 2 here and the 6 probably here. Yeah, I see it because there's your 18. You can see an 18. You see the 18 and the 2? Yeah, yeah. And Josh, you said it. You said positive 2, negative 6, right? Totally agree with you, okay? So now, we're ready to get the answers. So the answers are going to be x squared equals 0, 3x plus 2 equals 0, and we'll do an x minus 6 equals 0, right? This one's easy. X equals 0. Twice, but x equals 0. 3x equals negative 2. X equals negative 2/3, right? Subtract 2, divide by 3. Okay. Add 6, x equals 6. So there's my zeros by factoring. Okay, so if you want the full credit for that problem, you've got to factor it, all right? So now, let's go ahead and graph it, all right? So I'm going to put it on my calculator. And I'm just going to go to my y equals, clear that, 3x to the 4th period, subtract 16, x to the 3rd power, subtract 12, x squared, right? Graph it. Now I may have to adjust my window. I don't know. Alright, so something weird's happening in here, but I kind of already know what's going on in there because I have the zeros, right? So just for right now, let me pull the calculator away and let me do at least this much of what I have, alright? Alright, let me go ahead and draw in my graph. Let me take and put down what I do know, okay? Alright, so if I do this and this, okay, I know I'm going to have a 0 at 0 and at negative 2/3, which is right about there, and at 6, right? 1, 2, 3, 4, 5, 6, okay? Okay, so if I compare what I have with my calculator, it's got to go like this. A little bump down here. That's a double root, right? So that's why it goes through 0 twice, right? And then it's going to shoot way down. Now, how far down? I don't know yet, right? It's going to go way far down, right? How can I find that?
Your local min.
Let's go with my window, and how far down do you want to go?
100.
Okay, why not? What the heck? It doesn't hurt to go too far, does it? Because you'll find it. Lane says 100. Oh my goodness! All right. All right, Lane.
We do not have 500.
Okay. Oh, 500. Now the problem is we lost We lost everything in here, didn't we? Which is okay. We'll come back to what's up here. So let's get this minimum, right? So let's go second calculate minimum, right? And left bound. Enter, right bound. Enter, enter. So it's about a negative 4.45. I'm sorry, positive. So my minimum is way down at a 4.45 comma negative 471. Okay, there's my minimum. That is a minimum because there's two minimums, right? Yes. Yeah, yeah. So there's one minimum way down there, okay? Now there's another minimum right here. Right in there, right? Okay, there's another minimum there. So I'm going to have to really change my window to go back to that one. Make sense? So I want to zero in on this one. So I'm going to go back to my window. And to find that one, I'm just going to probably go negative 2 to 2, right? And probably we can go a height of negative 2 to 2. And we ought to see that small little area in there. So totally change my window to take a look at that spot. Okay, graph. Oh yeah, there it is, right? So now I'll do the same thing, right? Now I already know my maximum. You guys agree? What's my maximum? What's the maximum? 0, right? 0, 0. But so let's go for the minimum. So we calculate minimum, left bound, enter, right bound, enter, guess. So I've got another minimum at a negative 0.45. Comma negative 0.85. Alright, and then my maximum is at 0, 0. There's my min, and my max. And we've done this before, right? We have done this. We've done it with other polynomials. Hopefully we're getting good at this stuff, right?
Should I use negative 0.8?
Negative 0.85, yeah. Yeah, I'll write it down. Okay. And behavior. This is so easy, but you have to write it the way I want you to write it, okay? It needs to be written like this. And behavior. Okay, watch. Please write and behavior like this. As x approaches infinity. That's what this means. X arrow infinity. As x approaches infinity. So as x is going to infinity, what's y doing?
Getting bigger.
So you go y approaches infinity. Does that make sense? As x gets bigger and bigger, y gets bigger and bigger. To the positive infinity, right? As x approaches negative infinity, where's y going? Up, which would be positive infinity. See how easy that is to write? That's in behavior. That's all you have to write, okay? And in calculus, it's the way you have to write it, okay? Mr. Barrett used to let the kids do arrows, arrows. I'm like, I can't just do arrows, arrows. Come on, you gotta get ready for calculus. So anyway, I'm a lot more picky than Mr. Barrett. Great teacher though. But you got stuck with me. I'm picky. Okay, ready to turn the page?
No.
All right.
What was the last minimum?
There you go.
I can't read the yellow thing.
Oh, I'll rewrite it. Negative 0.45, comma, negative 0.85. There it is. And I just got that from, you ready, Levi? Right there. Do you see it? Yeah. Okay, ready to turn the page? All right, let's turn the page, all right? Okay, so, number 5, divide. All right, how do you want to divide?
The easy way.
Right. Yes, totally agree. Which would be called synthetic division, right? So let's do synthetic division. All right, so I'm going to take x minus 3, and really I want to divide by 3, right? We're really going to divide by 3, not negative 3, right? Because I solved for it. So I'm going to put my little upside down division sign. I'll put my 3 here, right? And I'm going to go 1, 11, negative 17, and 55. Now, if there's a missing term, put in a 0. If you're missing a term, but you're not, 3, 2, 1, right? You're not missing a term. But if you are missing a missing term, put a 0. Okay, put that little line across, and your 0 The remainder goes there. That's my remainder box, right? Okay, step 1 is just to bring down the first term. Okay, bring it down. Bring down the 1. And then we're going to multiply, right? 1 times 3 is 3. Then we're going to add. 11 plus 3 is 14. Multiply, I think that's 42. We're going to add, we'll kind of subtract really, but 42 minus 17. Clear. 42 minus 17. 25. Multiply, get a 75. Add. 55 plus 75 is 130, okay? Now that is not the answer. That is not the answer. You need to put the answer, and the answer is, you ready? Okay, the answer comes from here. There's where my answer comes from, but I need to put the x's back in. So we're going to go back and call it a 1x squared plus a 14x plus a 25 plus 130 over, what do we divide by? X minus 3. There you go. Nice job. Okay. Now, did it go in evenly? So is x minus 3 a factor? No. So you say no, and you have to say why. It's as easy as this. Why? Because the remainder was not 0. Okay, if you get a remainder of 0, then it's a factor, right? It goes in evenly. But you have to write that, okay? You have to explain, just simply because the remainder was not 0. Now, if the remainder is 0 tomorrow, you're going to write, yes, it's a factor, and say why. Why? Because the remainder is 0, okay? All right. I'll wait for you for number 6. Ashley, just tell me to move whenever you want, okay?
Okay.
I like those notes. Okay. All right. You guys ready for the next one? So, next one. We've got number 6. I have p of x. So I've got find the remainder, 3x to the 5th plus 4x to the 4th minus 4x cubed plus 7x plus 3. And if it's divided by x plus 3. So first of all, there are 2 ways to do it. Lane, which way do you want to do it? Go ahead and say it, the easy way. So that you could do synthetic division. You could. But there's synthetic substitution. Do you remember synthetic substitution all? Synthetic substitution says let's plug in -3 and the answer is the remainder. That's what synthetic substitution. If all you care about is the remainder, then just plug it in and the answer is the remainder. So to get the remainder, I'm going to take 3 and I'm going to plug in -3 to the 5th plus 4 times -3 to the 4th minus 4 times -3 cubed plus 7 times -3 plus 3, okay? And whatever answer we get is the remainder. It's called synthetic substitution. So, here we go. 3 parentheses -3 to the 5th plus 4 times -3 to the 4th minus 4 times -3 to the 3rd power plus 7 times -3 plus 3. -315 would be the remainder. If you divided it, the remainder is going to be -315. But by doing synthetic substitution, you just plug it in, gives you the remainder. That's easy, isn't it? Okay, that's easy. Okay. All right, 7 and 8. These are the ones you're not going to like because you're going to have to do the F word. We're going to have to factor, okay? Okay. You got it? All right, here we go. Number 7. factor. All right, so I've got p of x. So to find all the zeros, set it equal to 0. X cubed plus x squared plus x plus 1. 4 terms, group them. 4 terms, group them. Put these two together, put these two together, okay? So 4 terms, pair them up, okay? Group them. We're going to do by grouping. So what do these first two have in common? More than just x. X squared. Let me put a 1 right here so I can take out the x squared. So if I take out the x squared, out of these two I'd be left with an x plus 1. What do these two have in common? Just 1, right? Just 1. So I pull out the 1, I'd be left with an x plus 1. Now when I do grouping, the whole point of doing grouping is to get to the point where I have the two terms have something in common, right? What these two terms have in common is a parentheses x plus 1, okay? And I like to cross it out when I get done pulling it out so kids don't write it twice. Just write it once. What's left over? X squared plus 1, okay? Now we're not done. We factored it so you get your 1 point. To get your other point though, we need to end up solving it, right? So to solve it, set them equal to 0. So if 0 equals x plus 1, 0 equals x squared plus 1, right? Minus 1, minus 1. One answer is negative 1. Okay, minus 1, but I'm going to need to square root it. So I'm going to go plus or minus the square root of negative 1 is equal to x, because I square root, right? Now, what is the square root of negative 1? I. So my other two answers are plus or minus I. Okay? I sure can. Yeah. Yeah, there you go, Gerardo. You can do this tomorrow. I have faith in you. You're smart. Okay, are you ready for 8? I got to do the pre-calc down at the college with my daughter last year, and I really got a chance to see exactly what they do. And it's just exactly this stuff here. The only difference is there's no retakes. Right? Okay, turn the page. Okay. Number 8. So we've got 0 equals x to the 4th minus 24x squared minus 25. Okay? So I'm thinking x squared, aren't you? Thinking x squared, Does that make sense? X squared, right? And then what are the multiples of 25?
5 and 5.
But there's a better one. The one I want, it has to be 25 and 1. How come? Why is 25 and 1 the one I want?
24.
I need to make the 24, right? So if I go a minus 25 and a plus 1, I'll get the negative 24x squared, right? Okay, so I've got it factored. You pick up your 1 point. Okay, from here then, let's set them both equal to 0. 0 equals x squared minus 25. 0 equals x squared plus 1. Okay. Plus 25. 25 equals x squared equals. Square root, I get plus or minus the square root of 25. Well, that's easy. That's just plus or minus 5. So 5 is an answer, negative 5 is an answer. Okay, the other, I'll go minus 1. Square root, right? So if I square both sides, I get plus or minus the square root of negative 1. But that is... Say it louder. I. Plus or minus I. Thanks, Octavio. There we go. Can you do that tomorrow? Maybe. Okay. Yeah, because these I's, your calculators aren't